Hello, this is a video to cover chapter 15 in our textbook, which talks about integrated production process or processes. As you may remember, we needed to think about the company as a whole when we think about ERP systems and how we can make the company more efficient and more effective in achieving its goals. Technology may help us with that, with some of that anyway, and of course give us quite a bit of flexibility and visibility in real time of what's happening in the company. In previous chapters we talked about accounts receivable, order entry and accounts receivable. We talked about placing order with suppliers and accounts payable. So those are sort of the two ends of the company, one dealing with customers, one dealing with suppliers. But inside the company, and assuming it's a manufacturing company, this is the system where we need to focus more on managerial accounting or cost accounting. And we try to improve every step of the way. Of course, because these are all internal processes, we have full control on how we do it, and that's where most of the gains can happen in terms of improving efficiency, effectiveness, and so on. The products that the company produce are continuously changing. So we have to be able to accommodate that. One of the ways to do that is, in addition to ERP systems, we use other product design related systems. How can we design products in an efficient way, make changes as we go without costing the company too much time or too much money? To be able to evaluate this process, the whole internal production processes, we have to think about it as an efficiency group of processes. That means we need to calculate throughput time. The throughput time is the time it takes from the moment we say, yes, let us produce a product, until we actually do it and completed, ready to go as finished products. As we said before, in manufacturing we may use one or of two strategies or both, depending on what it is we are producing. So for example, if we are producing to the general market without detailed identification of where we will sell and who will buy and so on, we call that push manufacturing. Push manufacturing means we will produce and then based on sales forecast, and then the salespeople will have to figure out how to sell these products. So we tend to do that when the market is fairly predictable, and the salespeople know what they can sell and they tell us and we do it, typically in large batches of production, so we can gain efficiency, so the price per unit can go down, or the cost per unit can go down. Pull manufacturing is based on actual customer needs. So we can survey the customers, and then we can, based on that, we can start to build based on demand, work our way through the company backward toward our suppliers. So we say, okay, the market needs this much. That's from actually the customers, not the salespeople, and we can produce that much by going backward to our suppliers and order the quantities we need and so on. So push means we push to the market and try to sell as much as possible. That's when the market is predictable. When the market is not predictable, we use a pull strategy, because then we almost do it like manufacturing on demand, as opposed to just general production. When we think of that, we have to think about how do we produce. We typically use raw material to produce the products we want. If we have a forecast for what needs to be produced, then we have to look at our inventory and decide what, based on the current inventory, what are we capable of producing. And we call that capable to promise planning. So we put it on reserve. When we say promise, means we are promising what we have in inventory for a specific batch of production. Now, what is available is everything that we have. And how do we know all of that? Is by figuring out data from all kind of sources, from sales commitments, from inventories, from plant production, and so on. This way we know what we have and what we need to designate as promised for the production batch that we need to do. And systems can help us with that. So they can keep track of actual inventory and what's on reserve or promised and what is left in addition to that. Now, if we don't have enough for the production, then we have to think about going through the whole process we discussed before in relation to placing orders with vendors and get shipments and add to the inventory we have. Once we have that inventory and we have it promised, so it is committed to the production batch, we also have to divide all the steps needed in production into activities, and we use activity-based costing, which is a method of dividing all the big processes into smaller and smaller steps that we can figure out the actual cost of every step and the capacity also of every step. This way we will know if this step is becoming a bottleneck in the production and if this particular step costs too much money compared to the total cost of the product. And that will help us effectively manage what they call the life cycle cost, the sum of all the costs from all the steps in the manufacturing process until we produce the product. So not just the raw material, but the labor, the equipment, the machinery, time, the labor, and so on. Now, in the integrated production process, we have five major steps. The first one is to design the products. How can we do that efficiently? And if we need to make changes before we go into production, how easy is it to make change and how cheap is it to make that change? Then we need to look at the factory and generate a master schedule. Now, the factory is typically divided into stations, and not all stations are used to do a step in the production for all products. So every product has a route. It goes through some steps. Another product will go through different steps, and so on. So we have to figure out a master schedule. Every particular station has its own schedule, but then how we put it together and try to figure out the flow of production, and without having any particular station sitting idle at any time. Then we have to, based on those two pieces of information, of course, we have to have those. We have to have the master schedule and the design. Then we have to figure out what is the need for finished products. What are the salespeople telling us in terms of what we need to produce? So we have finished goods inventory, and we subtract that from the market demand, and that will give us what we need to make in our factory. Based on all of this, we start to plan and develop a detailed production instruction. And once we go through the production, of course, we record the manufacturing events and keep track of the actual cost. In the first step, when we are designing products, there is now, of course, software called computer-aided design, CAD, or computer-aided engineering, K. Sometimes there is another package called computer-aided manufacturing, CAM. All these pieces of software, what they do is enable the engineers to design products in software. And they can do it in 3 dimensions. They can look at it from different angles. If this particular piece of the product need to fit with another piece, they can have them both in software and make sure they fit and they can work properly together, and so on. The design of all of that can also be downloaded to the production machines. So the production machines know what dimensions need to be, this particular component of the product need to be in terms of size, in terms of material used, in terms of a lot of other factors that determine how to do it. So we can automate from design to actual production. If there was a flaw in the design, it's much easier to fix it in the software and try it again, make sure it fits with other components that it need to fit with, and so on. So this particular software is not part of ERP, but it does work with ERP in terms of integration, and it makes the manufacturing process much more accurate and easy to achieve. So this way we improve the design productivity. If we need some lead time, like time enough to design before we actually get into production, then we have that time and we can be very efficient at it. More importantly, because we already test the product and its fit with other components, or one component with other components, in the software, we can enhance the quality of what we are trying to produce before we actually produce it. So that test for quality later can be much more efficient, and of course reduces components that need to be reworked or to be thrown away and redo, and so on. Now, there is something called the bill of materials. The bill of material, think about it as all the ingredients that need to be used to produce a product or a component of a product or a part of a product. So, but that's based on 1 unit. So if I want to produce 1 unit of a particular product, what is all the material I need to have? Now, if we have the bill of material for a particular product, 1 unit, and then we know that we need from, like we know from sales, that we need to produce 1,000 units, then it's easy to multiply 1,000 by every ingredient in that bill of material to figure out the total quantity we need to order of each, or we need to get from the warehouse, from the inventory, raw material inventory, to be able to produce the batch that we need to produce. Of course, if we don't have enough in our raw material inventory, that's when we place an order with the suppliers. So we do the bill of materials to figure out 1 unit of the product, and of course we need the master file for that lists all the specification of how this raw material should look like, and then of course we need to understand how one unit will be routed through the different stations at the factory. With these three informations, we can figure out what would it take to produce one unit, and as I said, we can use it to figure out the time and the raw material needed, all the component for all the ingredients that we need to use to produce the full amount of what salespeople want from us. Process planning, or computer-aided process planning, is another piece of software. It's actually a decision support system that can generate for us from previous history and from the operations instructions and routing instructions and raw material, is basically the machining required. This will help us figure out the amount of time we need on each machine in every station in the factory. So this is called computer-aided process planning. How long it will take to process every step of the way throughout the factory to produce a particular product. Now, the work center master, these are the different stations that we have been talking about. Each of them has its own little schedule, and somehow through the routing with the software will help us to find the most efficient way to route or produce different products at the same time and route them through the factories without disrupting one production or another. The master production schedule, of course, that's where we are doing all the requirements for using the factory. All the time we need, when we need each station, how much time we are going to use the machines in every station to produce the total quantity of products that we need to produce. So at every step, of course, we need to, all of this will be to help us plan production and control it. Now, with the material required for production, they call that material requirement planning. Along with the master production schedule that we will have from about all the machines and so on, along with the bill of material, as I said, we use the bill of material and the work in progress to figure out what are the quantities needed from every ingredient that we need to put in our product. And that may then force us to calculate what they call time-phased order requirement schedule. Meaning what? We have to sort of stage the different quantities, the different batches that we need to do in order to produce what the salespeople tell us we need to do. So the process of taking the bill of material for one product and make it expanded or exploded to figure out all the material we need for that product, but not just one unit, but for all the units we need to produce. This is a process called exploding bill of material. So we take one unit and then all the ingredients get multiplied by the 1000 we need to produce. So every little quantity of any material get multiplied by 1000 totaled, and that's when we have the exploded bill of material. We compare it to what we have in inventory. If we have it, great. If we don't, then we use what we have in inventory and order the rest. So this exploding process, here is the bill of material to produce one mousetrap, and then what will happen if we multiply every item here by 500 to get all the material required for producing 500 mousetraps. Of course, there is also another piece of software that can help us figure out what they call capacity requirement planning. It uses information from the master schedule, it uses information from labor and machinery, and try to figure out what is the maximum production we can do using the resources we have. This area is very important because the engineers can help us improve the machinery, for example. Training may help us improve the labor. Automation will definitely help us improve the labor requirements. And that will increase the efficiency of the factory. Meaning what? Meaning we can produce more with the same machinery. So this capacity, with some tweaking, can improve quite a bit, which means, of course, we improve the efficiency of our resources, and that helps the company reduce the cost per unit produced, and eventually, of course, or in turn, help us improve profitability. Now, in the factory, of course, we have to have some kind of authority to say, okay, now we're going to produce some product and a certain quantity. And this is called manufacturing orders. This is to authorize dedicating the factory resources to produce certain products batch, so for only a certain amount of time. So as you know, we have raw material we need to acquire. So we issue requisitions if we don't have it already in inventory. And if we have it in inventory, we may have to issue a requisition from the factory to the warehouse to acquire that and move it from the warehouse into the factory. Once it gets into the factory, it becomes work in progress. And then, if the factory can produce different things, we can like different products, there may be downtime because the machines have to be retooled. So the machines are set up in a way to produce a particular product. Now, if we need to produce a different product, how easy it is to change the configuration of the machine to do a new product. And with the CAD software that can help us, of course, design and then the new product, and with the factory changes, we can then produce another product. Of course, factories in general try to minimize the amount of time they need to set up the factory machines for a new product, because that setup time is overhead. It is not producing anything, so we try to minimize that. So the more we have to produce with the same configuration, the better, because we don't have to lose overhead time in changing configuration. Of course, all the information about the factory, the designs, the decisions, all that data has to be stored into what we call automated storage and retrieval system. Why? Because that will help us later get the data, analyze it, and figure out better ways to improve. There is another piece of software. In many factories, robots are very much in use, and including some small vehicles that are driverless. There is nobody to drive these little vehicles. They are automated. Robots or computers drive them, and there is a special software to do that. Part of it is where to tell the vehicles where to go, but another part is, if we have many of these vehicles, how to avoid collision. If one vehicle moving in a certain way, the other may have to hit it. It may have to stop, allow the first car to pass by, and then move after that. So we don't have disruption to the business. We talked about just-in-time inventory when we discussed in chapter 12 how inventory is accumulated by placing orders from suppliers. And the idea was we're not going to bring from suppliers anything except what we absolutely need for a few days. This way, the factories, whenever they need something with the master schedule, we know what they're going to need, then we have it already in inventory. They can take it from inventory, but by the time they need another set of materials from the raw material warehouse, then we have had another shipment and we get it just in time. Big part of that is to try to keep the factory going at all times. We need to make sure that also we don't have any downtime, but we also have zero defect in the material we order. So our products that we try to produce are not, don't become defective themselves. We need to make sure that there is total quality control from the point we place an order with a supplier. The quality of the raw material we are getting is exactly what we need, and we bring it just in time for the factory so we can minimize the cost of inventory. And at the end, with the AutoCAD and AutoCAM, the CAD and CAM will help us also design the product in a way that minimizes defects. So it's a total quality control from the origins all the way to the finished product. Of course, we will need, as I said, to record manufacturing events. Everything we produce, all the steps in the manufacturing process, we need to be able to track it, and we store the information for future analysis. We get some managerial reports that have to do with the throughput time. How long did it take from the moment we said go, produce a product, until we got a product, finished goods. The productivity information, how efficient were we in using the company machinery and labor resources. The quality of what we produced, and of course with the objective of minimizing rework or defects or rejects. Activity-based costing, all of that need to be tracked. We also need to be able to track the vendor performance. Did they deliver what they said of all raw material on time with the quality expected? This will help us evaluate our relationship with the vendor in the future. If they deliver good quality on time, obviously they're reliable, we can depend on them. If not, perhaps then we have to look for somebody else. So cost accounting, of course, work in this area very well in all of these points by comparing standard costing with actual costing and figure out the variances. So once we get the details of everything, we come up with a standard, when we call it standard cost. For a particular product, how much material needed, the cost of that, how much labor needed, the cost of that, overhead, cost of that, and then we have the cost per unit. We use that information for future production. However, if we find through the processes that we have that we did not or were not successful in meeting the cost that we had before, obviously then there's something wrong with what we are doing, and using activity-based costing will help us figure that out. However, if we find that we improved on previous processes, that means we have done a good job and we can continue, and perhaps next time we modify the cost to reflect the new efficiencies that we achieved. From a managerial point of view, of course, we have to look at everything. If we think about throughput, we have to think, for example, with time it takes to place an order with a supplier until we receive it, until we the money involved, the time, the quality, and so on. The human resources, all the labor that is involved. Uh, the purchasing process, inventory management, all these processes are used, as we said, cost accounting, figure out the basic cost based on history, and then we compare with actual cost for the new batch through the variance analysis. The record standard, recording standard cost, as I mentioned, has to also do with trying to estimate the cost of work in progress. As you know, at the end of a financial period, like the end of the month, for example, if we need to take inventory of raw material, that's easy to do, it's in the warehouse. Finished goods, that's easy to do, it's in the warehouse of finished goods. However, the work in progress, how do we evaluate that cost, is by using how many units, what is the percentage of completion of every unit at the different stages in the factory, and based on a standard costing, what is the value of the work in progress of all these incompleted parts. Now, when we get to the point where we need to close the manufacturing orders, like we produce the final products from the work in progress, we need to record in the general ledger what happened. How much of that work in progress got converted into finished products. And of course, not everything in the factory we can track or relate to one unit of production of a product. So these things, we call them overhead, manufacturing overhead. And of course, these are basically, you take the total cost and divide by the number of units produced, and this way you get a good approximation or average cost per unit for that overhead, which get added to the price of each unit in terms of production cost. Once we finish everything, we of course need to look at both inventories of raw material and finished goods and reconcile what we have done, evaluate the just-in-time inventory that we did in buying raw material, and perhaps also just-in-time inventory for sales. Did we have enough products to sell when the salespeople needed them to sell, or were the products just sitting in the finished goods inventory and nobody's buying? So it's a continuously ongoing processes to balance raw material inventory to help the factory produce products, to produce products just in time for the market, so we don't accumulate inventory at either end. Now, in terms of fraud connection, most of the fraud in the manufacturing process will happen in relation to inventory, either raw material or finished goods. It may be that we have enough frequency of small fraudulent activities that become material over time and can be huge. So we definitely need to keep track of that. That may require physical control, I'll put it under a lock, and also recording control in the system, so we don't have discrepancy between what is actually in the warehouse and what is in the system. So we can do counts, simple count, Again, when we issue a list of products that should be in the warehouse, we don't put quantity. We ask employees to count what's in the warehouse and then compare it through the system with what's actually in the system. This way the employees counting don't know what is in the system, and we can figure out if we have any difference between what actual and what's in the data. We have to also figure out some level of control over obsolete inventory. If our products get obsolete quickly, if they get damaged, if they get broken in some way, we have to account for that. How much of the inventory actually got damaged and why, with the objective of trying to minimize that. Sometimes inventory in the raw material warehouse, we record receiving something in inventory, but for some reason that doesn't go to accounts payable. So it's not recorded as outstanding in accounts payable. So we have to make sure, again, through the order entry and payable information, that we are reconciling on a regular basis to make sure that what we received is recorded and paid for. So there is nothing in inventory not paid for, because that will mean it can walk away. The computer can help with that in terms, as I said, in terms of taking physical inventory without and print a list of what should be there without putting quantities, and then once we finish the physical inventory, the system can compare. We input what's in inventory physically, and the system will compare with what should be there, and this way we can keep track of what's going on. As I mentioned, in terms of effectiveness, we can also address some of the issues related to inventory. Do we have enough inventory in raw material for manufacturing without running out? And do we have enough inventory in finished goods so we are not affecting customer needs, or we are meeting customer needs, while in both cases trying to minimize the cost of carrying inventory, so we just buy just in time and produce just in time. Again, we can do quick checks on inventory if we have things like RFID. We can have somebody with a scanner from a distance can count what's in inventory, and this way we can quickly do a quick check on one item here and one item there. In terms of efficiency, again goes back to time and employment of resources, machinery, people, and raw material. So combination again between physical inventory and system controls. This way we have control over the whole production process.